Yesterday, we have looked at a brief overview of end-to-end life cycle of the data science project, right? So let me just do a recap of that quickly. Then we'll start with the actual topic for today's discussion, right? First, we get in touch with the business teams to understand the business problem to the level of granularity that is required. Then we understand the source of the data and what all the variables, the features that we need to consider to solve that problem, and what aggregation level that is required to roll up the data to be able to solve the predictions, the forecastings, what we would like to come out with, right? And as part of that, we start with data collection, data cleansing, data wrangling, and slicing and dicing with respect to the problem what we are solving. And on top of that, we perform the feature engineering to understand whether the features that we have selected are good enough for us to be able to predict or forecast the output variable that we are trying to come out with. Once we're done with the feature engineering, that's when we start with the model building by partitioning the data into training and test with various experimentations with different proportions we try it out. And whichever the model that gives us the best performance, we're going to pick up. Ultimately, we are not going to develop a single model for solving a problem. Once we go through all these algorithms, then you would be able to understand what all algorithms we can make use of to build the models for solving a certain kind of problem, right? Out of all this, then we evaluate the performance of the models between training and test and across the models, and we pick up the best performing model based on the performance, right? Finally, we understand the overall architecture of the system, and to be able to deploy that into the production with the help of production deployments or architects, whoever takes care of it. And we are not just done with by deploying the models into the production. We'll keep that into the maintenance mode. We keep monitoring the performance of the model for a certain period of the time to understand the accuracy of the models. If it is going fine, that's perfectly fine. If there are any glitches that we observe with respect to the performance of the model in the production, then we pull back the model into the maintenance mode. We collect the data again, including the latest data, and we rectify the problem what we are seeing with the model performance, and we again deploy it back, right? And this is the overview of end-to-end life cycle that we have discussed yesterday. And today, we're going to discuss about the basics of statistics. We are starting with the basics. So it's going to take about 16 to 20 hours of time, including the basics of R programming, basics of Python programming. And I would request everyone to send an email to sales team to get the basics of R programming and basics of Python programming sessions, recorded sessions added to your LMS so that you can go through in the next 5 days of time frame at your convenience. You don't need to attend them. At your convenience, you just open those recorded videos and go through at your own pace. Okay. So as part of the basic statistics, the agenda of what you're seeing on the slide is a list of topics that we are going to discuss for next 16 to 20 hours, right? We're going to start with the data types. What are the types of data that we generally deal with? And how do we understand the type of the data? What are various things that we take into consideration to be able to determine the types of the data? Because these data types and the measurement scales are far most important for us to be able to select the relevant algorithms for solving the problem. And that's the reason we give complete essence in terms of understanding what data types the data belongs to. And thereby, we will be in a better position to be able to select the relevant algorithms for building the models or for resorting to different techniques that we're going to discuss in the next few hours, right? And alongside of data types and measurement scales, we will be discussing about the random variable, probabilities, probability distributions, and various types of probability distributions. And then we will start with measures of central tendency, which is about mean, median, mode, measures of dispersion, and Why can't we just rely on measures of central tendency? Why do we need to look at the dispersion measures as well to get more insights about the data? And skewness, kurtosis, and various graphical representations to understand the distribution of the data, to find the outliers, right from the histograms, box plots, right? Then we'll get into the scatter plots. Slowly we'll start with the linear regression. Of course, linear regression we will not be covering as part of the basic statistics. Once we start with the machine learning, that's when we're going to pick up the linear regression, right? And towards the last of the basic statistics, we're going to discuss about hypothesis testing, which is a backbone for us to prove whatever the assumptions we make about the business problems, whether the assumptions are correct or wrong. To be able to determine statistically, that's where this hypothesis testing is very useful, right? Am I clear, friends? Online folks, you can stop me anywhere. If you have any questions, feel free to ask the questions. Okay, fine. Even before understanding the terminologies and the conceptual understanding about the terminologies, let's use our common sense, okay? What is this, what you are seeing in the first diagram? So what would be the outcome of by looking at a clock? We get to know the time, right? What kind of data type do you think the time belongs to? Integer? Is it a whole number always? We can represent the time to any level of granularity, right? Hours, minutes, seconds, milliseconds, microseconds. And we can go to any level of granularity that to measure the accuracy of the measurement, right? So that means, and the second one, the money, currency. Can we represent this also to the level of granularity? Right? Rupees, paise, and even the digits that we represent the paise and the subsequent measures, right? Length, meters, centimeters, millimeters, right? What is this? Laptops, number of laptops. Can I represent this to the level of granularity? No, right? It has to be a whole number. We cannot have half laptops or quarter laptops. It has to be a whole number. How about this? Number of cars, whole number, right? And how about this? Anybody married? Angry wife with something in her hand. What the husband is going to get? The beatings, right? Can I represent the beatings in the decimals? No, right? It has to be a whole number, irrespective of the intensity that's being applied, right? So if we can represent something, the format of decimals, and it makes sense, and it has got some meaning associated with it, that's called continuous data type. For example, the time, currency, length, height, weight, yeah? All these can be represented to any level of granularity that is required through the representation of decimals. And still there is some meaning associated with it. Clear? Now, something which cannot be represented in decimals, which has to be a whole number, or which could be the categories, like male, female, in case of gender, right? So the customer is going to be defaulted in paying back the loan. Yes or no? Will be defaulted or will not be defaulted, right? So mutually exclusive classes. We cannot have a value which is somewhere in the middle of these two classes. It has to be either S, he is going to be defaulted, or no, he will not be defaulted, right? And these kind of data types are called as discrete data types. The variables which hold the whole numbers or different classes of values will be treated as discrete data type. Can you think of some examples for the discrete data? Applications are valid or not? The loan applications, any applications, yeah, perfectly fine. And what else you can think of? Yeah, Boolean value, true or false, right? And what else? The occupation, number of males and females. Yes, of course. Yeah. And the city you would like to prefer to live in. Okay, though they're labels, each of them is completely different from the other, right? These are all discrete data. Am I clear? Online friends? Lina, Praveen, Shamolima, Subramanian. Fine. So it's not just good enough for us to understand what type of the data it belongs to. In order to be able to select the right techniques from a statistical perspective, we need to get into the next level of details about the data that we are examining. And that's where the measurement scales comes into the picture. We have 4 types of measurement scales. And of course, it's going to scale about a given measurement. Accordingly, we need to decide which of these scales the respective measurement belongs to. What is the measurement? Length, weight, all these are measurements, right? If something has got just the label associated with it, like our names. If I just tell my name to someone who is stranger, will he be able to get any sort of information about me apart from the name? What kind of information he would get? Sorry? Religious. Oh, that's a very good thing. Okay. Gender. Okay. And some names are very hard to bifurcate between the genders, right? Okay. So, but more than that, we can't get any more information if I just have the label information about any measurement, right? If I just tell the city name without getting into the next level of details, what kind of decisions we can make with respect to the objective that we are trying to attain. Hence, it's very hard to compare just the labeled information, just the names. And that's where, if you have something which is just got the label, the respective measurement scale is treated as nominal scale. Coke and Pepsi are two soft drinks. If I just have the labels without any further information with respect to how many customers are liking Coke or Pepsi, or what is the kind of sweetness that have got each of these drinks have got in it. Okay, if I just have the names, it's very hard to compare. But moving on from nominal to ordinal, ordinal tries to bring the preference associated with the data along with the name. It brings a sort of preference as well. Preference or the direction. I prefer Coke to Pepsi. Means there I'm bringing some comparative measurement between the two soft drinks. Thereby, I can choose one which would have been better, right? So this is called ordinal scale. So moving from nominal to ordinal, you will have the preference or the direction associated along with the labels or the names. Thereby, it gives a bit more information than the nominal scale. Right? Well, even it's not just good enough for us to be able to draw a conclusion by comparing different products, different services we examine. Moving from nominal to ordinal to interval, it brings a magnitude with respect to the comparison. Interval, as the name suggests, out of a scale of 10, if I ask you to rate, how much do you like Coke? How much do you like Pepsi? Would I not get more information than the ordinals? Definitely we'll have more information, right? We have some quantitative measures associated now over a range of intervals. But again, these interval scales are pretty much local to the sample that you are analyzing. Sample means, if I'm just conducting a survey within this classroom, like out of a 10 scale, 10 rating scale, how much each one of you like the respective drinks, soft drinks. Though there are some definitive guidelines, one might think 6 is a very good rating, though he likes it very much. The other might think 9 should be the good rating, right? Still, it doesn't bring the accurate measurement about the data that you are analyzing. The interval scale is pretty much local to the sample that you are analyzing. You cannot globalize the findings of your survey. Just a second, guys. Sorry for that. So what are the observations we make based on the interval scale? Though there is some magnitude associated with the data, we cannot really globalize our findings. A 6 rating, which I get for the soft drink Coke out of this classroom, can I compare the same 6 rating outside of this class if someone rate same as 6? Can I say both of them like to the same extent? No, right? There is still a difference. Some might think 6 would be the better rating. Some might think 6 would be the average rating. Okay. And moreover, when it comes to the arithmetic operations, we can perform additions and subtractions on the interval data, but not the multiplications and divisions. Moving on from interval to ratio. The ratio brings the absoluteness towards the measurement. These measures are going to be on the globally accepted scales. If I capture the heights of the students who are part of this classroom, will I be able to compare the heights with anyone who is outside of this classroom? Because the height I'm going to measure using centimeters or feet and inches, which are globally accepted scales. Right? Hence, as we move from nominal to ordinal to interval to ratio, the level of information that we are able to capture from each of these measurement scales would keep increasing. So from an analysis perspective, we would always expect something which is of a ratio kind, as long as it is possible, because it gives complete information, right? Which can be easily compared with other measurements. If I have a data set, I'll have a combination of variables. Within a particular variable, if the measurements are taken on a globally accepted scale, would I not be able to compare between the rows of the same variable? Would it be possible or not? Now I capture the heights of all the students. Right? So can I look at the heights that I measure over the centimeters scale, and will I not be able to compare and draw a conclusion in terms of who is the tallest, who is the shortest, what is the average height in this classroom, and so on and so forth? Yes, it is possible, right? And coming to the arithmetic operations, we will be able to perform all 4 kinds of operations when a ratio data is given to us. Am I clear? Any questions so far? Online folks? Okay. So the data types, continuous and discrete. The measurement scales, we have 4 different measurement scales: nominal, ordinal, interval, and ratio. What is a random variable, friends? A random variable describes the probabilities for an uncertain future numerical outcome of a random process. Do we understand anything by going through this definition? If you take any statistical book, this is the definition that you're going to have for the random variable. Okay, we don't need to strain so much. Let's split it into two parts, random and variable. We all know what is a variable. A variable that accepts all possible values, right? One of the several possible values. And random. What is a random? When you perform an experiment, there's always a possibility that an equal possibility or probability associated for all the possible outcomes to be an output. Means, if I'm flipping a coin, what are the possible outputs when I'm flipping a coin? Head or tail, right? So we have two outputs, possible outputs, head or tail. Flipping a coin is an experiment. What is the probability that is associated to get head as an output? 1/2. What is the probability formula, friends? So we'd like to understand the possibility associated for an outcome out of all the possible outcomes, right? Number of interested events divided by total number of events. Number of interested events or number of desired events divided by total. So when we are flipping a coin, what are the total number of possible outcomes? 2, head or tail. But we are interested in which outcome? Head. So that is number of interested events is 1. That is 1/2, which is nothing but 0.5. The range of values that probability accepts is between 0 and, what is the range of values? 0 and 1, right? The same thing can be represented in percentages as well. 0.5 means there is a 50% chance that would get head as an outcome. So the probability associated of a random variable x having an output as head is 1/2, 0.5. Random variable is always represented using capital X. The probability of a random variable x having an outcome out of the possible outcomes is represented using small x, is equal to number of interested events divided by total number of events. And similarly, when I'm rolling a dice, what is the probability that I would get an outcome of 3? 1 by 6. How about getting a 4? 1 by 6. That means there is an equal probability associated for each of the outcomes to turn out be an outcome of an experiment. Right? Even in case of flipping a coin, we already looked at the probability associated with head being an output is 1 by 2. Then what is the probability associated with tail being as an output? 1 by 2. So that means there is an equal probability associated with all the possible outcomes of an experiment. And that's what the random means. A variable, the capital X, which takes any of the possible values with an equal probability associated, is called the random variable. Am I clear, friends? Online folks? Anybody has got an internet issue? People are logging off and logging in. Okay, fine. Now, how many cards will have in a deck? 52. How many symbols we will have in a deck? 4 symbols. How many colors will have in a deck? 2. Men are always men. Right? Okay. Now, what is the probability that if I pick a card from the deck of 52, that the picked card would be greater than 10? Greater than 10. Consider A as 1. 12 by 52. Greater than 10, how many cards we have in each symbol? 3 cards are there. J, Q, K. Right? We have 4 different symbols. 4 threes are 12. The probability formula is number of interested events divided by total number of events. So the number of interested events are 12. Divided by the total number of cards that we have is 52. Sorry. Yeah, I already told that let's treat A as 1 for the time being. Right? Now, what is the probability associated that a card being picked is equal to or greater than 10? 16 by 52. P of X being greater than or equal to 10 is equal to 16 by 52. How many of you think this is correct? This is correct? Yes, of course. Equal to 10 or greater than 10, how many cards we have? 4 for each symbol. 4 4s are 16 divided by 52. But don't worry, I think all these things will be shared to you. Okay. 16 by 52, right? But if I didn't replace the card which I picked at the first instance, now tell me what is the probability associated for the card which I'm picking up would be greater than or equal to 10? Sixteen by 51. 16 by 51. Is there any other possibility apart from 16 by 51 if I didn't replace the first card? 15 by 51. When it could be possible? When the card which I picked up at the first instance, if it is already greater than or equal to 10, then I'll be left with only 15 cards out of this 16, right? 15 by 51. Am I clear? And this is called conditional probability. Means the outcome of an experiment is influencing the outcome of subsequent experiments. The card which I picked up at the first instance, if it is not greater than or equal to 10, then the probability of getting a card which is greater than or 10 is greater than or equal to 10 is 16 by 51. The card which I picked up at the first instance, if it is already greater than or equal to 10, then 15 by 51 is the probability associated, the card being greater than or equal to 10. And this is called conditional probability. And do remember this, we are going to make use of the same logic in naive Bayes algorithm when we solve the classification problems. Okay. And no more tricks further. Let's be straightforward. Let's say I already replaced the cards which I picked up the first two instances. Now, what is the probability associated a card being smaller than 3? 8 by 52. Clear, friends? Everybody? We cannot afford to go wrong in these basics. If you don't understand, please let me know. I'm happy to repeat again. Okay. Now, what is the probability that a card being picked Yeah, sure, Shyamoli. The conditional probability is all about the output of an experiment would be influencing the output of subsequent experiments. Here, in case of the current exercise, what we are doing here, the experiment is nothing but picking a card from the deck. If I pick a card at the first place, the probability associated that card being greater than 10 is 12 by 52. We are all clear about that, right? So the outcome of your first experiment is 12 by 52. Now, if I don't replace that card, and now if I decide to pick up another card from the leftover 51 cards, the probability associated with the card being greater than or equal to 10 could be 15 by 51 or 16 by 51. Depends on what card I picked up at the first place. So this is nothing but the conditional probability. Am I clear, Shyamoli? Okay. So now what is the possibility that A card being greater than 4 and less than 8. 12 by 52. Greater than 4 and less than 8 means we are looking at these three, 5, 6, 7. The overall 12 cards are there, 12 by 52. Clear? Now, let's look at the probability distribution. Can you please go through this problem statement? The data that we have in the table are about the daily sales of the TVs in a particular store. X is being the number of TVs being sold, and probability of capital X is nothing but the random variable with the respective number of TVs being sold. The probabilities are given, right? Now, can you tell me what is the probability of a sale? Point 0.6. Sure. Everybody? Online folks? What is the probability of a sale? Now, friends, you can unmute yourself and speak out. You don't need to type everything over the chat unless and until you have too much of background noise. Let's make it interactive. So what is the probability of a sale? Online folks, Hema is the host, I think. Leena, Shamolima, Subramanian. Okay, fine. Question is, what is the probability of a sale? A sale means at least one TV is being sold, right? At least one, how many cases I have? All these 4 cases are representing at least a sale. Now the probability, if you just sum up of all these 4 probabilities, you will end up in getting 0.60, or else you can take out the no sale probability. That means there is a 40% chance that none of the TVs are getting sold. That means there is no sale for that day. What is the maximum value that probability can take? 1. 1 minus 0.40 gives you 0.6. That means there is a 60% chance that a TV is being sold. What is the probability of selling at least 3 TVs? At least 3 TVs. 0. Yeah. At least means greater than or equal to 3. 0.15. We need to add up both these. If I ask you what is the probability of selling 3 TVs, then 0.05. Right? At least 3 is different from just 3. Okay. So if I plot the number of TVs on the x-axis and the respective probabilities on the y-axis, which plot do we get? A typical bar plot, right? But in bar plot, we always look at only one axis. Here we are taking the probabilities as well into consideration. If you have probabilities on the y-axis and the respective x on the x-axis, then it's called probability distribution. Now, can you tell me, is this a discrete probability distribution or continuous probability distribution? How many of you think it is continuous probability distribution? Whenever we are talking about the data types, let it be continuous or discrete, we always need to look at the base variable, not the associated mathematical expressions about that base variable. The base variable x is number of TVs. So what data type is the x here? Can I represent the number of TVs in some decimals? No, right? They are whole numbers. So it's a discrete data type. So if I plot the probability distribution for a discrete data, it becomes discrete probability distribution. Now, can you think of some examples for a continuous probability distribution? The price you're talking about, the quantity, okay. But here, when we are taking discrete data on the x-axis, and with respect to its probability, if we plot a graphical representation, it's quite clear that there are no values somewhere in the middle of these discrete values because they are the whole numbers, right? There's a clear distinction between the values of your x. But if I take the continuous data, let's take the height of the people across the world. If I just attempt to plot the same, right from 3 feet till 10 feet. And the respective probabilities. What is the probability that a person is having a height of 3 feet? What do you think is the probability? We're very less, right? We hardly find people with 3 feet. Still, this is possible, right? And similarly, the 10 feet is also very less. But at the same time, if I just take the whole numbers, 3 feet, 4 feet, 5 feet, 6 feet, 7, 8, 9 feet. So would my probability distribution is as clear as the discrete probability distribution? No, right? We definitely have people between these whole numbers who are having the heights 3.5 inches, 3.2 inches, 3.25 inches, right? 6.4 inches. So it will be somewhat like this. So between 4.5 to 6.5, we will have majority of the people. Again, it starts coming down. Right? So when we get into normal distribution, we will discuss more about the behavior of a continuous data. What is the normal distribution? Right? Just plot, connect all these graphs. We see something like a bell curve, right? Have you ever heard about the bell curve? Where do we generally come to hear about that? The appraisal cycles or managers keeps using it, right? Irrespective of how distinct you are from the other people, they'll try to make you sit at a particular rating, right? So we'll talk about the normal distribution a little later. So the probability distributions can be of two types, depends on the underlying the data. Discrete probability distribution and continuous probability distribution, right? Any questions so far, friends, online folks? Because these are the basics that we are trying to understand. I'm not using any softwares, either R or Python. Okay. Once we reach to the graphical representations, I'll start making use of this. I would request everyone to come along with the laptops, at least for next Saturday session. Right? So there won't be any break next Saturday and Sunday, friends. We'll have a continuous sessions, 2 to 6, same time. Yeah, you can. You will be given, you will get that email with the link and everything. Did you get the LMS access? Yeah, you will get a notification. You can just click on that link and join that session. The same way like our current online participants are joining, you can attend the same way. Yeah. No, not required. You'll automatically get it. Did you get your LMS credentials and everything? And then you must get it. If you miss out, just ping in our group. You're part of the WhatsApp group as well, right? I'll share the link. Yeah. Yeah. Oh, is it? Why don't you just shift here? Just come over. How about others, friends? Is it visible? Or it's okay, right? Generally, the projectors are a little blurry compared to the actual screen. Okay, fine. But why are we learning about probabilities? What kind of problems we can solve by applying the probabilities? Let's look at a couple of case studies. Who is there in the first picture? Angelina Jolie, right? What happened to her? Any idea? Because of the genetic reasons, and she was not suffered with the cancer by the time she was undergone the treatment. But still, because of various genetic reasons from her ancestors, from her mother, And the doctors have examined all the medical records. And they come out with an estimation that there is a high probability of getting a mastectomy cancer. Mastectomy cancer is very dangerous, and because it starts eating the parts of your body. Even before the cancer was attacked, she had undergone the treatment and she had removed the respective body parts as part of the surgery. Predictive analytics. Even before you get into the problem, predict what is going to happen and take the respective precautionary steps. Let me just open the article. The risk associated with the genes is not simply an exact figure like 87%. The doctors have come out with a probability of 87% she might get attacked by that kind of cancer, because of which she has prematurely has gone into the surgery, right, to save her life. You can just go through this in detail so that you can understand the complete details about it. And the other case study that we are going to look at is about Amanda Knox. She was basically working as a nurse in one of the hospitals during a particular shift, that in a night shift. Slowly, the hospital has started observing that there are more deaths being recorded during her shift times under her supervision. Even though there are no specific evidence was available that she was the reason for those deaths, filed the case, and the court has given a statement for her for a lifetime imprisonment. Then her family has approached a statistician saying that she is not guilty of that particular crime. Please help to prove that. Then he started survey, analysis, research across various hospitals which have got the similar kind of environment where different people work in different shifts, people have been joining. Yeah. And based out of his analysis, he managed to prove the court with the stats that the number of deaths recorded under her supervision was pretty much lower than the average deaths that have been recorded across the hospitals, the sector of healthcare. Then the court had to release her because they don't have any strong evidence against her being committed any crime. Right? And that's the probability, the power of probability that is there. And whenever we get a chance to work with healthcare industry, we should be very cautious. 95%, 96% accuracy of the models that we build are nowhere good enough, right? Because that directly leads to the lives of people. Hence, you cannot afford to go wrong with your prediction, right? Fine. Now, let us look at sampling technique. And generally, whenever there are some elections going on, about to go on, even after the elections have been conducted, before the results have been out, a lot of exit poll firms which comes out publish the results about what they think based on the research that they have done. Based on the reliability of the firm, we pay attention towards the respective results that the exit polls are being published. But what exactly do you think? How these exit polls will be derived? How do they come to a conclusion that a party would win this number of seats? Do you think that they reach out to all the people who are part of the voting system, who voted in the elections to get to that conclusion? No, right? It's very costly stuff. Right? They cannot afford to reach out to each and everyone who voted in a particular election. Rather, what they do is they pick up a sample of the people. And that too, that sample selection should be in a way that's a representative of your complete population. In terms of economic status, in terms of being benefited by the government policies, in terms of representing different economic classes, right? In all these respects, your sample should be representative of your population. Only then the result that you obtain by analyzing the people of sample would be intact, same as our population, right? Now, let's understand a bit in detail. Let's say Reliance Fresh would like to float a new retail store in a particular locality. They see an opportunity that there would be a business growth in that area. First, they take all the people who are located surrounding that location, right? But at the same time, does it really make sense to analyze all the people who are staying in that locality with respect to the objective that opening a store in a locality? Doesn't make much sense. So you have to be refined towards your objective always, right? So being a market analyst or financial analyst who work for the Reliance Fresh, if I come out with various parameters that are the most important for me to decide, which could help to decide whether to open a store in that locality or not. So what kind of parameters would help me to analyze opening a store in that area would be beneficial or not? What do you think are the parameters? Parameters are nothing but the features or variables or attributes about the people who are staying in that locality. The average income of the people who are staying in that locality, number of residents, sorry, the competitive stores, yeah, So the total population in that locality. Competitive stores. And what else might influence the decision? Yeah, the age group and the gender. Yeah, there also matters, right? Age, gender, based on the business problem that we are solving. This is the sort of research that we perform to understand what are the most important features for me to analyze to take a decision about my business problem. And we would need to get into the next level of details. If the average income is about more than only 30K, then I would see a break even within next 6 months or 8 months. So this is about the next level of details, right? Based on the parameters that we think would influence the decision that we are trying to solve, or the problem that we are trying to solve. And we are going to prioritize those parameters as well. Which are the most important, which are the next most important, right? If I take the average income is being more than 30K as a first and foremost priority for me to be able to decide whether the store which I'm planning to float would be beneficial or not. So setting up a criteria at your parameter level is nothing but the sampling frame. So based on the criteria, I'm extracting the intended population for my analysis. So out of the population, by setting up a criteria, I'm extracting a group of people who are interested of my analysis, right? On top of the sampling frame, we have different sampling techniques. One of the renowned techniques is simple random sampling, SRS. By applying SRS technique, I'm going to randomly extract few people, which would be a right representation of the entire population that I'm trying to analyze. By applying this SRS technique, simple random sampling, we managed to extract the sample. Why do we need to extract the sample at the first place? Why can't we perform our analysis on the population itself? It's very costly affair, right? Reaching out to all this population and understanding the details about the parameters, what you think of might influence the decision that you're taking is a costliest effort. Though we do have the information available, can you really afford to perform your complete analysis on the population? Let's say we do have the data about the complete population lying in a database. And your manager asked you to perform an analysis and come out with a decision or a suggestion whether I can go ahead and suggest the business to open a store in that area or not. Can you really analyze the complete population data of that locality and come to a conclusion. What kind of infrastructure do you need to be able to analyze the complete population data? Let's say if the complete population is about 2 to 3 millions. With the kind of infrastructure we used to work, i5s, i7s, 8 GB RAMs, 16 GB RAMs, with the CPUs, is it really possible? No, right? And that's where sampling technique has got its importance. Simple random sampling is a very powerful technique in terms of randomly selecting the observations. What are the observations? That each record that I have in my data set is nothing but a combination of your rows and columns, right? Each row represents about a customer. Each column is about different parameters that are what I'm taking into consideration. And simple random sampling swiftly manages to collect a sample which is of the same proportion of your overall population data. Because of whatever the reasons, the computational expense and the time it takes, and if you'd like to perform the survey in terms of reaching out to the people and putting across the questionnaire to them and getting the answers back, and again uploading all that answers, and then analyzing that, you cannot afford to spend days and days of time to get the first level of feedback. And that's the whole reason sampling has got gaining the fame over analyzing the complete population data. So once we obtain a sample which is a representative of the population data, then we perform the complete analysis on the sample, not on the population. By performing the analysis, whatever the results or the conclusion that we make about the business problem that we are solving, do we talk about only the sample or do we extend it to the complete population when we are publishing our results? Complete population. Though the exit polls take a sample of people into consideration for analyzing, they'll obviously say that this is about complete India. These are the number of seats BJP is going to win. These are the seats Congress will be limited to, right? So that means the results that we obtain out of the sample analysis would be extended or extrapolated to the complete population. We will never talk about just the sample. So that means we are inferring the results of a sample back to the population. Hence, it is called as inferential statistics. Clear? To get a faster feedback, or if you don't have enough time to complete the analysis to the extent it is required, that's when we have to rely on extracting a sample out of the population, which is of the same representation in terms of all proportions, carry out your complete analysis on the sample and infer the results back to the entire population. But provided you're given the required infrastructure to be able to compute the complex levels that are involved in the volumes of the data that you are considering. In case of if you have provided the GPUs, TPUs, or distributed computing architecture, like you have multiple nodes being running, which will be sharing the load of the computations that you perform. Right? So there you really don't need to think about sampling. But ultimately, we don't go with the big bang approach. Irrespective of the volume of or the size of the problem that we are solving, we always feel like seeing whether solving or taking up this problem is beneficial or not. To get that first feedback, it's always good to go ahead with a simple sample. It could be based on simple random sampling technique. There are various sampling techniques that are available to us. Stratified sampling, cluster-based sampling, various advanced sampling techniques that are available. So I would request you guys to spend some time reading about what all various sampling techniques that are available and what exactly we perform in each of these techniques. To give you a hint, simple random sampling, stratified sampling, cluster-based sampling. Of course, we are not discussed about the algorithms. Don't worry about cluster-based algorithms. Sorry, cluster-based samplings. But still, just read about it. Okay. Clear, friends? Any questions, online folks? Let's take a break for 20 minutes, come back and continue this session. All right? I'd like to grab a cup of tea or biscuits. They're kept in the terrace. Just walk over, have a cup of tea. Online folks will just come back by 3:50. Are you with me? Okay, fine. Four measurement scales. What are they? Nominal, ordinal, interval, and ratio. If you just have the labels of the names, we call that as a nominal scale, right? And we can't get more than the name. We can't get any more information other than just the name. And when we move from nominal to ordinal, what extra information do we get in the data? We get a preference or the direction in terms of comparing two data points. When I move on to interval, what extra information do we get compared to ordinal? We'll have the magnitude. Or a scale of values, we'll get a magnitude in terms of how one option is better than the other option. It brings more flexibility for us to compare between the data points. And is it a local scale or globally accepted scale in case of interval? It's a local scale. Okay, it's very much local to the sample that we are analyzing. But when we move on to ratio scale, what kind of arithmetic operations we can perform? Addition, subtraction, multiplication, and division. All four kinds of operations we can perform. Because there is an absoluteness involved in the data when it comes to the ratio scale, and which is measured on a globally accepted scale, right? And how do we represent the random variable? Using capital X. What is the formula for probability? Number of interested events or number of desired events divided by total number of events. How many types of probability distribution we have? What are they? Discrete probability distribution and continuous probability distribution. And the results that we obtain over the sample, if we infer it back to the population, what do we call that as? Inferential statistics, right? There are various sampling techniques. One of them is simple random sampling, stratified sampling, cluster-based sampling, right? And do spend some time to read about what all various sampling techniques we have. Okay. Now let's move further. It will never be a sample. Yeah. You'll always get a population data. Not population in the sense in terms of the people. It's a complete data you will get. And based on that, depends on the kind of problem what you are solving. You need to determine what is the size of the sample that you would like to obtain to get the level of feedback that you are looking for. If your infrastructure supports and time permits and your management of the business teams are giving enough time for you, you can go ahead and analyze the complete data, right? Given the data to us, from here onwards, we're going to learn some techniques. What kind of analysis we're going to perform on a univariate space? When I say univariate, a single variable. Taking a single variable at a time from our data, the variable or features or dimensions or columns are all one and the same. These are different names that people will be using. Okay. The observations or rows are nothing but your records, right? On the univariate space, we need to understand how the data has been distributed. Towards that, the first step that we are going to look at is measures of central tendency, which is also called as first moment of business decision. As the name suggests, these measures talk about the concentratedness of the data, the centrality of the data. That's why it is called as central tendency. The first measure that we're going to look at as part of measures of central tendency is mean. Mean or average. Whenever we look at any of these measures, we need to think both from population perspective as well as the sample perspective. The measures under population are called as population parameters. And the relevant measures on the sample are called as sample statistics. And all the population parameters will be denoted by which notations? By the Greek notations. There are the Greek notations. Okay. The mean of the population is denoted by, how do you pronounce this? Mu. The mean or average of the population is denoted by mu. Okay. The formula is nothing but simply add up all the data points. There's nothing but, how do you pronounce this symbol, friends? Sigma. This sigma is for summation. Sigma of xi. X being the random variable, I is nothing but the values it takes. First need to sum of all the values divided by the total number of values. Total number of population values is also called as population size. The population size is always denoted by capital N. Right? Now coming to sample mean. Sample mean is represented by X bar. The formula remains the same, but the notations differ. Instead of population parameters, you need to represent them using sample statistics. Summation of xi divided by small n. Small n is the sample size. Clear? Fine. We are talking about the basics. Let's understand the logic with the very simple examples. And slowly we'll keep increasing the complexity of the data set, a volume of the data that we're going to look at, right? Now let's say this is a random variable x. I have some values like 1, 3, 5, 70, some random values, 24, 56, 87. Is it visible, friends? Random variable x having the values like this. Okay. Now, what is the size of the population that I've taken here? 7, right? There are 7 values, right? How do we calculate the average or the mean? Sum of all the values divided by 7, which is the number of values, capital N. 35.14 is the mean that I get for this data. Let me take the same data. But this time, instead of 87, let me take 870. Now, if I calculate the mean of it, what happened? the mean value has been shifted from 35 to 147 just because of a change in one single value, right? So that means your mean tends to get influenced by what you call these 870 compared to the other values. Large values are outliers are extreme value, right? Why we are calling that as an extreme value? If I'd like to plot these values, let's say this is the x-axis. If I take 5 values in the interval of 5, 10, 15, and so on, right, till 1000. All the remaining values would lie somewhere here. The 870 would be somewhere here. That means there is a definite scaling difference between the other group of values to the extreme value that we are considering. And that's why we are calling that as an extreme value or outlier, right? If you have extreme values or outliers in your data, your mean tends to get influenced. What kind of interpretation we can bring in for the mean? What exactly is the mean? When we take a group of data which has been spread across like this. So the measure mean tells us where the majority of the data is concentrated. And that's what the measures of central tendency tells us. But because of one single outlier, your central tendency measure, which is the mean, tends to get shift from one place to the other towards the extreme value. Because mean has got such tendency of getting influenced by the outliers or the extreme values, don't ever rely upon the mean to take any decision. Am I clear? Then, which measure we can rely upon to take any decisions? That's where subsequent measures of central tendency are introduced. The second measure of central tendency is median. What is the median? The middlemost value of the data, right? What is the middlemost value of this data X? As the definition suggests, it is 70, the middlemost value. We have total 7 data points, out of which whichever is existing at the middlemost position is nothing but the 4th position is the middlemost position, is 70. But is 70 is the median for this data? Should be arranged either in ascending or in descending before calculating the median. Arrange them in ascending order: 1, 3, 5, 24, 56, 70, and 870. Now, what is the median of this data? 24. Though there is an outlier in our data, is median got influenced by the outliers? No, right? It still stays at the similar level. And that is where median can be relied upon to understand the centrality of the data, though there are extreme values or outliers are existing in your data. Am I clear? That's fine. Since we have 7 values, just straight away taken the middlemost value. Let me add one more value to it. Don't need to rearrange the order again. 970 is definitely more than all other values. Now tell me, what is the median of this data? We need to take, because these are even number of values, we need to take the middlemost values. What are the middlemost values? 24 and 56. We need to take the average of both the values. Clear? Can I calculate mean for this data? What type of data is this? String, float, boolean, characters, integers. Let's forget about the programming terminology for a time being. Is it continuous or discrete? Let's only concentrate on these 2 data types for the time being. Discrete? Sure. Right? Anybody thinks it is continuous? Cannot be continuous. Cannot represent that in decimals. The clear categories. How many categories we have? Red, blue, white, green, yellow. 5 categories are there. Right? Each of these categories are mutually exclusive from other categories. It can be one of these 5 categories. Cannot have any middle value, right? So can I calculate the mean for this data? What is the mean formula? Sum of all the values, sigma of xi divided by, if you think this is population, it's capital N. If you think this is sample, small n, right? What is this xi? What exactly this I represents? The values of x, right? What is x3 in this data? Nothing but the third record, third value, right? So the formula for the mean is summation of all the values divided by the total number of values. So we cannot apply mean for discrete data. So can I calculate median for this? No. And that's where the third measure of central tendency is introduced, which is nothing but mode. Mode is nothing but most repeated value or the most occurring value in your data set, in your variable. But tell me, what is the mode of this data? Right? How many modes we have? How many modes we have in this data? One mode. Most occurring value are the most repeated value. Which is the most repeated value? Red. So that means we have single mode. So if you have a single mode in your data, that's called as unimodal. Unimodal. If I remove this last data point, now what is the mode of this data? Blue and red. So how many modes I have? Two modes. Bimodal. If you have more than two modes in your data, that's called multimodal. Unimodal, bimodal, multimodal. Can I calculate mode for continuous data? Yes. So what is the mode of this data? 70, because it is repeated twice. Clear? So the mean, median, mode talks about centrality or the concentratedness of your data, considering a variable at a time. Clear, guys? Any questions? If you are calculating mean for population data, that becomes population mean. If you're calculating mean for sample, that becomes sample mean. Okay. If you take the complete population of the people, the previous sampling funnel example that we have taken, if you think that about 1 million people are staying in that locality, whom you would like to target in terms of by opening a store. So the complete data of this 1 million becomes your population data. But by applying various parameters or criteria with respect to your business problem, you are extracting a sample out of it based on different techniques, like average income greater than 30K, right? Various other, could be any parameter, could be any criteria. So let's say by applying some criteria, you manage to extract after applying this simple random sampling. If you end up in extracting 5K records, so this will be your sample. But the difference why we are trying to understand between the population parameters and sample statistics, you will come to know the significance of both of these as we move forward into the subject. Clear? Yeah, any other questions? Yeah, we can calculate the median, the middlemost value for the ranking data as well, or the count data, but it doesn't make any sense. It doesn't make any sense. For the sake of calculating, yes, we can, but it doesn't make any sense because each of those values, the rank values or the count values, have got no relationship with other. Each of them are mutually exclusive, right? Yeah. That means there is no mode for the data. And mostly the mode measure we make use of on the discrete data, the categorical data. Going forward, we will be seeing a lot of case studies there, you will understand. Okay. Online folks, any questions before we move further? Okay, fine. As the mean tends to get influenced by the outliers, we had looked at other two measures, the median and mode. But are the measures of central tendency, nothing but the three measures, mean, median, mode, are they good enough for us to get the complete information about the data of any variable? Not definitely, because they just simply talks about the concentratedness of the data, the centrality of the data. It doesn't talk about the other attributes about the data. That's where we're going to learn about the measures of dispersion. You can also call this as measures of dispersion, measures of spread, measures of variance. And this is also called as second moment of business decision. Measures of central tendency is called as first moment of business decision. The measures of dispersion is called as second moment of. But what exactly the measures of dispersion is going to tell about, what kind of information it is going to reveal about the data, which cannot be revealed by the measures of central tendency. Right? Let's take a simple example. How many of you follow cricket? Everybody must be following, right? Okay. Okay, fine. How many balls needs to be bowled in an over? 6. Right? What is the circumference of the cricket ball that needs to be qualified by IC? No idea. Okay. So it will be between 224 to 229 millimeters, the circumference of a cricket ball. For it to be qualified by an ICC, so that the ball can be used to play a match. What is the lower limit of this circumference? 224. Upper limit? 229. And what is the average of these two? 226.5. Now, let's say ICC has opened up a tender for new manufacturers to accept the balls being manufactured by them for the next 1 year of cricket play. Now, there are 2 vendors who are finalized. Vendor A and vendor B. Now, ICC asked them to come out with a manufacturing of 10 balls from each of these vendors for the testing purpose, for the quality check. Now, the vendor A, by using machine A, he produced 10 different balls. And vendor B, by using machine B, he produced 10 different balls. When they bring those balls for the quality check, then ICC, what it has done is, it has just plotted based on the circumference of the balls that each of these vendors came out with. Machine A produced the balls, which looks like this. Right? And machine B has produced the balls, which looks like this. Now, which one do you think would get qualified? B. The reason? Accuracy, uniformity, consistency, right? So there is a consistency with respect to the output that vendor B is coming out. So effectively, we are measuring the spread of the data from its mean. How can you measure the spread? Let's say this is 227.5. Numerically, how much of the spread that this data point is maintaining, how can you bring out that measure? Nothing but we need to calculate the distance of each of the data points towards its mean, right? The mean, expected mean is 226.5. We calculate the distance of each of the data point towards its mean. Thereby, we will understand the overall spread that is involved with machine A production. And similarly, we'll come out with the spread that machine B produces. And whichever the machine comes out with the lowest spread, that will be qualified for the bidding, right? So that means, what is the underlying measure that we are relying on to come out with the spread? The mean, right? We are baselining the mean value to understand how far or how deviating your production is from the mean. So that's where your measures of dispersion gives more information about the spread, which is nothing but the consistency with respect to the services or the production, in addition to the measures of central tendency. It's not just good enough to look at the measures of central tendency. We also need to look at the measures of dispersion to get more information about the data. Yes, of course. I'm taking just an example as the mean will be 226.5. Obviously. Then obviously, when you're comparing between two samples, the spread also will be varying, right? And similar to measures of central tendency, we have three different measures for measures of dispersion or the spread or the variance. The first measure is variance. The population variance is denoted by, how do you pronounce this? Sigma square, right? This sigma is different from this sigma. This one is a summation. This one is a variance, sigma square, right? And the formula for variance is summation of x minus mu whole square divided by n. Why do you think we are squaring? We're simply calculating the distance between each of the data point towards its mean, right? In the previous slide, when we discussed about the spread, we were simply taking the distance of each of the data point towards its mean. Why do you think we are squaring it? The difference can be negative as well, right? And that's the whole reason we are squaring it. The distance cannot be negative. The difference can be negative, but the distance cannot be negative. That is the reason we are squaring it, right? Let's say this is the data I have, simple data, just to understand the logic. What is the mean of it? What is the mean of it, guys? Oh. When there is an equal interval between the numbers, then obviously our middlemost value will become your mean, right? Now, what is the formula we are using to calculate the variance? X minus mu. Let's calculate x minus mu first, then we will square it. Now, what do you think x minus mu for the first data point is? X minus mu is nothing but the mean, which is 4 minus 3. Right? So the difference can be negative. The difference of from the first data point towards its mean, we got minus 3. The second data point minus 2, minus 1. Since the distance cannot be negative, we need to square it. And how are we calculating the variance? We are taking a summation of it. Summation of x minus mu whole square. Divided by capital N. Capital N is nothing but number of data points. How many data points we have? So this is nothing but your variance. Clear? The population parameter for the variance sigma square is equal to summation of x minus mu whole square divided by n. Now, what is the sample variance? We represent the sample variance by S square. S square equal to summation of x minus x bar whole square. What is x bar? Sample mean, right? We represent the sample mean by x bar. X minus x bar whole square divided by n minus 1. But whereas in case of population parameter, we have just n in the denominator. But when it comes to the sample, we have n minus 1. Any idea why do you think there is a difference in the denominator? Let's say this is how population is distributed. Let's say it is normally distributed. The bell curve is nothing but the normal distribution. When the data is normally distributed, you will have the mean of it exactly in the middle, because there are no outliers, the normal distribution, right? This is mu. Now, we're talking about the sample statistics. Irrespective of however the effective technique that you make use of to extract a sample from the population, irrespective of the effective techniques that you make use of to extract sample from a population, do you think it will be 100% representative of the population? I'd like to study about 1 million people. I managed to select 5,000 people out of them. Irrespective of whatever the accurate method I make use of, will I be able to represent all the attributes that I would see in the entire 1 million people through this 5K people, 5,000 people? No, right? It's never possible. So there is always a deviation possible. Hence, let's say, but whatever the effective technique that you have used, this is the sample you managed to extract. Sample is also normally distributed, let's say. And since the center, the sample mean also lies exactly in the center because it is also following normal distribution. And this is, how do we represent the sample mean? X bar. But you are analyzing the sample, and whatever the results that you are obtaining based out of the sample, you are inferring it back to the entire population. You are talking about the entire population. I analyzed this 5,000 people. As per my analysis on this 5,000 people, I feel opening a store in this locality would definitely be beneficial. I'll not talk about only this 5,000 people, right? I'll talk about the entire 1 million people. There, you can go wrong with respect to the deviation that you have between the population and sample, with respect to the attributes that they have been represented with. Researchers have understood that, and they have done various experimentation, thereby to reduce the gap between your sample mean and the population mean, or to boost up your sample mean towards the population mean. That's where this n-1 is introduced in the formula of variance. But if I go down by 1 in my denominator, would it really boost up the sample mean to reach the population mean? So in the denominator, I'm reducing the actual value by 1. What kind of effect it will have on the overall value? The overall value will increase or decrease? Will increase because you are going down in the denominator. And that's how the sample statistics are getting boosted up to represent the same what the population parameters are representing. And you can have a question. Why only n-1? Why can't I go down by 2, 3, 4? Why can't it be n-2, n-3, n-4? Why it is only n-1? And the researchers have performed various experimentations on huge volumes of data pertaining to different sectors. At n-1, the results are more optimal. That is the reason the n-1 has been fixed to boost up the sample mean to reach to the population. And this n-1 is also called as degrees of freedom. Degrees of freedom. To explain the concept of degrees of freedom, I'll take a simple example. Now, I'd like to purchase 5 books, but I have a clear guidance that you have to purchase 5 books, but the average of all the 5 books, the average price that you spent on all the 5 books should not exceed more than 50 rupees. I have 5 books to be purchased. And the average should not exceed or should be same as 50. That means how much amount is available with me to buy 5 books? 250, right? And the average price is 50. 5 books, 550 or 250. Okay. I've gone out to shops. And what should be the price of the first book that I can buy? Has it to be exactly 50 rupees? No, right? I have the complete freedom to choose of my own wish. Let's say I've selected 70, a book for worth of 70 rupees. Now, how much of freedom I will have in case of purchasing the second book? So out of 250, I already spent 70. I'm left with 180. Still, I have a lot of freedom, right? Let's say I purchased a book worth of 60. I'm left with how much? 120. So slowly, as I move towards the lesser number of positions, my level of freedom is keep decreasing. Now, let's say I have purchased a book worth of 40. We're left with 80. And then I purchased a book of worth of 50. Even till n-1th position, let us say the overall number of books as n is equal to 5. Even till n-1th position, which is the 4th position, I still have a lot of freedom. Even here, I can go for 70 rupees as well. Right? Till n-1th position, only we will have the freedom. But when I reach to the last position, I will not have any freedom in order to meet the criteria that has been set. So what should be the price of the last book? 30. So this is the concept behind degrees of freedom. Okay, am I clear, guys? The first measure of dispersion is variance. It's about understanding the spread of the data, spread of each of the data point from its mean, right? And the second measure of dispersion is standard deviation. What is the difference between variance and standard deviation? So if you look at the formula, what is the difference we can make out? We're applying a square root, right? Other than that, there is no difference. Just for a simple mathematical transformation, why do we need a measure altogether? Why do you think that just by applying a square root, why do we need to bring in a measure altogether? Because of the reason that let's say this is our original data. Let's assume for the time being that these are about the distance measured in centimeters. Right? Nothing but the units. Now, what would be the units of x minus mu? Centimeters? Because we are differentiating between the same units. The units of the result would remain the same. But when I square it, what happens to the unit? Even the units get squared. And when I calculate the variance, what would be the units of the variance? Centimeter square. Is there any meaning centimeter square or liter square or rupee square? Is there any meaning for that? There is no meaning associated with it. In order to get your original units back, that's where the new measure has been introduced called standard deviation. It simply applies the square root on top of the variance and even units will be back to its original measurement. And that's the whole reason there's altogether a different measure. No, originally the variance was introduced, and later on the standard deviation was introduced. Okay, and that's the reason if you take any of the statistical packages or softwares, the likes of R, Python, you'll have a default inbuilt functions for the standard deviation. Okay. Now, the third measure of dispersion to understand the spread about the data is about range. The range is nothing but the difference between maximum value of a variable towards its minimum value. By looking at the minimum and maximum, at a first level, we get to understand the spread of the data. The spread of the data between what values. If a range is too high, that means the data has been spread across a wide range of data, wide range of values. And at the first place, this helps us to get the first level of feel about the data in terms of the spread. Right? Now, let's take this particular case. Let's say there is a river. It's been flooding. And there are some evacuation teams who are actually moving the people from the flooded areas to the safe areas. And they have to cross this river. On one bank of the river, there is a caution board saying the average depth of the river is 4 feet. Now, can you afford to cross the river by looking at the caution? No. Why? It's only 4 feet depth, right? That's just an average. There could be a big pit somewhere in the middle where you would go and get drowned, right? That's where the averages cannot be relied upon. You need to look at the measures of dispersion or the spread of the data to get more level of information about the data, right? Pay the attention here, friends. Next, we're going to discuss about the expected value. And why do we need to expect a value even before it occurs? be prepared with the required resources, right? We've been seeing the companies, even the governments forecast the GDPs, the sales revenues for the next 1 quarter, for next 6 months. Why do they need to forecast? What is the requirement for them? So that they can be ready with the required resources to meet the respective requirements they will have by the time they reach to that time frame, right? And we've seen the probability distribution. The mean of the probability distribution is referred as the expected value. So effectively, we are taking the probability associated with the respective event will be multiplied, and taking a summation of all such events would yield the expected value. That means we are giving the relative weights for each of the event that is going to occur. Let's go back to the same example what we had seen. What is the relative probability that no TV is getting sold? 0.40. One TV, 0.25. Two TVs, 0.20. Three TVs, 0.05. Four TVs, 0.1. If you'd like to calculate the expected value, simply just take the summation of the product of the X values with the respective probabilities. And this will become your mu. If you repeat the same experimentation for infinite number of times, that's where these expected values is going to be same as your mean, mu value. Let's see it practically how it works. Okay. Now I've taken the same data. Is it visible, friends? 0 TVs getting sold. Probability associated is 0.4. 1 TV, 0.25. 2 TVs, 0.2. 3 TVs, 0.05. 4 TVs, 0.1. If I take the product of X with the relative probabilities, it will be this. If I take the summation of it, 1.2. What does that mean, 1.2? Does that mean on an average, I'll be able to sell 1.2 TVs? No. Can I say the same thing? Like in a 5 days of time frame, I'll be able to sell 6 TVs. Does it make sense? So effectively, on average, you are selling 1.2 TVs. The same thing, repeat the number of experimentations. I'm extrapolating the same thing over a period of 100 days, how this data looks like. Now, the number of TVs being sold as zero means no sales for about how much time? 40% of the time. If I take 100 days, out of 100, 40 days I will not have any sale. I will not have any sale. So first 40 days, I'm taking zero TVs. Right? First 40 days, I'm taking zero TVs. And how many days I'll be able to sell one TV? 25 days. That means from 41 to 65. I'll be able to sell one TV. Right? And what is the probability associated with 3 TVs, 2 TVs? 20. For next 20 days, I'm taking 2 TVs. Need not to be in the same sequence. That for the first 40 days, I'll not have any sale. It could be random. But overall extrapolation, it means the same. Okay. And for next 5 days, 86 to 90, I'll be able to sell 3 TVs. For next 10 days, I'll be able to sell 4 TVs. Right? Now, if I just take the average of all these, the TVs that I'm selling, on an average, how many TVs I'll be able to sell per day? 1.2. Means the same. Though you extrapolate to an infinite number of time frame periods to observe the data, or you simply take the probability associated and the number of the actual data, the product of actual data and the probability associated, and take a summation of it. Means the same. So that means, as a shopkeeper, I will have an idea in terms of, on an average, considering all the worst situations as well, I will be able to sell 1.2 TVs per day on an average. I may not be able to sell for the next 5 days, but definitely after that, I'll be able to observe some sales. So accordingly, I plan my operations. Accordingly, I plan my costs. And that's the significance of expected value. Am I clear? Any questions, or do you want me to repeat? And the same thing, if you apply on the variance, instead of summation, we are taking the expected value of x minus mu whole square. Expected value of x minus mu whole square is nothing but the summation of x minus mu whole square and multiply that with the probability, associated probability. Multiplying a data point with its relative probability is also referred as the weighted averages. Because we are multiplying the zero only with 0.4 because that is the probability associated with 0 TVs being sold. And one with 0.25. These are called weighted averages. We'll talk about more on these weighted averages when we discuss about time series forecast. Clear? Now, even before we move forward with the graphical representations, there is no fun in discussing about these graphical representations over the PPTs. We have to build them, thereby we can understand more about them, right? Even before that, let me introduce you how to install R and Python. Just make a note of the steps. When you come next week, please come with the laptops with both R and Python installed. So that I'll start with basics of R and basics of Python programming. And after that, we'll continue our discussion. Okay. Let's first see how to install R and RStudio. Just go to Google and say R download. Let's take first link. Any of you are using MacBooks? Anybody? Online folks? Anybody is using MacBooks? Shamolima, Subramaniam. Guys, please respond. I'm not an outsider to you. Okay? Fine. So if you are using Windows, just download R3.6.1 for Windows. Just click on this link. It will download for you.
Hello, can you hear me?
Yeah, I can hear you now.
Yeah, sorry, I was talking. I was on mute.
Oh, sorry for that.
Oh, sorry. Yeah, I don't have a MacBook installed.
Okay, no problem. Yeah. The reason why I'm asking anybody who's using MacBook is the installation process is a little different for the Macs. That's the reason. Okay, if you're using Windows, just go to this link. Just click on this link. It will download the setup file for R. Once it is downloaded, just double click on that. Just follow the instructions. The pretty easy and simple instructions. Next, finish. Don't change anything. The moment you install R, it looks like this. Both 64-bit and 34-bit, 32-bit, both will be installed by default. And choose the one relevant for your operating system. I hope most of us are on 64-bit, right? So just click on that 64-bit one. So this is how it looks like. A simple plain notepad. So you can perform any arithmetic operations here. Just run two basic arithmetic operations to see it is installed properly for you. Pretty simple installation, right? So once you are done with R download and installation, just again go back to Google. That is very pretty plain notebook kind of UI, right? We cannot make use of that for programming. We need IDEs, interactive development environments, to be able to manage our code in more intelligently and more cleanly, right? That's where company called RStudio has developed an IDE which can run on top of R. You can go back to Google and say RStudio download. Just click on the link, that download RStudio link. Just scroll down a bit. You need to understand few things here. RStudio has got both desktop version and server version, but we don't need server version. And at the same time, it has got the freeware version and licensed version as well. You see here, the first one, RStudio Desktop. It's an open source license, means it is a free. You don't need to pay anything for downloading this, for installation, installing this particular version of the RStudio. But there are some enterprises which encourage you to use only the licensed one. So there probably you could go for commercial license, which costs $995 per year, right? But even in the organizations, people go with the open source version itself. You don't need to buy a licensed one. Because most of the packages are available with the open source one itself, right? And the server version is not meant for us. Of course, there are designated features that comes along with the server version, unless it demands and the environment is set up like in your organization which you're going to join. You don't need to go for the server version. Just click on the download with the free version. You can just look at what all the features that comes along with this free version. That's only the integrated tools of R will come along with this. Just click on this link. The moment you click on download, it will take you to this. So out of this, you need to choose RStudio 64-bit for Windows 10, Windows 8, Windows 7. Select this. What is Ubuntu, friends? Linux, right? So if at all you are asked to work on Linux environment, so the Ubuntu version you need to download. Even the Linux, nobody is using the Linux flavor of the version from an operating system perspective when it comes to the analytics or data science. Because most of the tools that we work with, most of the softwares are very much interactive and integrated with Ubuntu OS. Okay. So make sure Ubuntu operating system is set up on your machine if you are asked to work with Linux, and load the respective softwares. Just click on this Windows 10. It starts downloading for you. Once it is downloaded, again, the same step. Very simple and easy wizard, installation wizard. Next, finish. Clear? Once you install RStudio, looks like this. This is how it looks like the moment you launch it. Now 4 different windows. The leftmost top pane of the window that you're seeing here is called a scripting window. This is where we write our script. Like this. Okay. Let's say +2. I can execute a line of code multiple ways. And just select the complete line of the code. Say run here. The result will be shown in the console window. The left side bottom window is called as console window, where the results will be shown to us. 2 + 2, 4. Or else, you can place the cursor anywhere on this line. Just say Control Enter. Even then, the line of code will be executed for you. Otherwise, you can go to the source window, the source drop down, say source with echo. Even that does the same. It will execute that script or the line of code. When I have multiple lines, see, the entire script gets executed if you go for the source with echo option. Echo means it gives the output in the console window. But if you choose just the source, the script simply gets executed. No result will be shown. What do you mean by sourcing a script? Once we are done with the compilation and the script is finalized, we maintain our scripts in different architecture level, right? The functions will be written in one place. and the pre-processing scripts will be written somewhere. The actual model building will be somewhere, right? You'll have a driver script which combines all these scripts based on the locations, and you just source it. You're sourcing a script. That means you're loading a script from a different location, executing it, and get your work done. That's it. Generally, in the productions, we go for this option. But most of the times, we don't use this UI button. Okay. If I simply say execute that script, source that script, and execute it through the commands itself, through the code itself, we will be instructing. Okay, there are different ways of executing a line of code or a script. But in the debug mode, to execute line by line, you can go for this control enter. Control enter executes only that line of code. Clear? Now, I'm declaring a variable and assigning a value to it. As opposed to any other high level languages, we don't need to write multiple lines of code to perform the same thing. Generally in Java or C++, how many lines of code you need to write to assign a value to a new variable? First, you need to declare the variable and define the type of the data it could accept, and then assign the value. I don't need to do anything here. If I simply say x is equal to 3, now in the variable explorer, the global environment window, the variables or the functions or the data frames or the storage types will all be displayed here. And the type of the data would automatically be assigned by R. And most of the times, it assigns the correct data type. Sometimes it might get misled based on the data we have. Some of the data might have huge number of missing values. Because of whatever the reason, if it cannot assign a correct data type, we need to change the data type of that and apply the relevant operations. Okay. Simply giving a set of random values and assigning it to the variable x. I'm building a bar plot on the x. How many variables do I need to build a bar plot? 2. Sure. To build any visualizations, any graphs that will be displayed in this area under the plot section. Would like to explore it. Yeah, you can see it, right? And we'll be discussing more about packages and the basic programming in next session. Okay, but come with your laptops by installing R and RStudio. Now we are going to see how to install Python and Anaconda as well, right? So once you install this R, please check if it is properly installed. And RStudio, just perform some basic operations like what we had seen. You can go to Google, say Python download. Download Python 3.8.0 for Windows. Download the latest version for Windows. Don't download the very latest version because these are all the beta versions which are still under testing. Go to this downloads, say Windows. So here it gives the clear information about what all the stable versions we have and what are the other versions we have. Under the stable versions, there are some disclaimers. See, Python 3.7.4 cannot be used for Windows XP or earlier versions of Windows, earlier operating systems of Windows. Just be cautious about the type of operating system you are in and the download, the version which you're downloading for installation. Nobody is on XP. Oh, but all you are there, please go for the even previous versions, 3.6 versions. 3.6 versions work. Even they are not used, they cannot be used on XP. Otherwise, if you're in Windows 7 or Windows 10, go for 3.7.3 version. These are all stable versions. So this is the link you need to click. For Windows 64-bit, the Python 3.7.3 version can be downloaded from this link. Executable installer. Download that installer and install it. And straightforward installation. Very user-friendly. Next, finish. Right? Once you install Python, Python is again very command prompt based UI that provides. So now we need to install the IDEs, Interactive Development Environment. Anaconda distribution say Anaconda download. Anaconda is a distribution which provides a combination of IDEs that can be worked with Python. Underlying your Python should have been installed at the first place. Only then you'll be able to install Anaconda and start making use of those IDEs to work in Python language. Similar to how RStudio works on top of R. Okay. Let's go to this Anaconda Python distribution, free download. Just say download here. It takes you to this page. And be sure that though it is displaying Windows installer here, Anaconda 2019.10 for Windows installer. Just click on this Windows button once again. Because sometimes by default, it takes you to the Mac OS. You just right away install the 3.7 version that doesn't work on Windows. So make sure you click on Windows and then download the Anaconda distribution software relevant to Python 3.7 because the Python version which we installed is 3.7.3, right? Then you click on this download and don't try it out here because it's very huge file. Make sure your internet speed is very good when you're downloading this and installing Anaconda, especially. Okay. Fine. The installation wizard is pretty straightforward and very user-friendly. So once you are done with that installation of Anaconda, sorry. We'll see something like this. Anaconda 3, 64-bit. If you open, you will see all these IDs, but first open the Anaconda Navigator. Takes time. You're loading. Whenever you are loading Anaconda Navigator, it takes time. This is how it looks like the moment you load it. All this what you're seeing on the home screen are nothing but various IDEs that Anaconda supports to work along with Python. But out of all this, we majorly use, I highly recommend you to start using the Jupyter. And after that, Spider. But start with Jupyter because this is the one highly used in the industry. But the underlying code that you're going to execute will remain the same. Whichever the IDE that you're going to use will be the same. Let it be on Spider, let it be on Jupyter. Code doesn't really change. Okay. So first time when you're launching it, you need to click on this launch button, which is there _ Jupyter. So then the Jupyter notebook will be open for you. If you load the Jupyter notebook, this is how it looks like. Right? This is how it opens. It's a browser-based IDE, which is very user-friendly and which is very easy for you to document your results, your analysis results, so that you can play back to the business when you are showcasing your observations or the analysis that you have performed. To play back that to the business, the Jupyter notebook is very helpful. Okay. So to open a notebook of Jupyter, you need to go to here, the new. This shows all the Python versions that you have. If you have Python 2 is already installed on your machine, it shows Python 3 and Python 2. But select Python 3 because at the first place you would have already installed Python 3.7.3, right? So this is the Jupyter notebook, and this is where you will execute your lines of code. Okay. To execute this, click on this run button. It gives the output. Even in case of the visualizations or the graphs that you're developing, it will be very neatly displayed. Even though you're loading a huge data set, it shows all the variables. That's not the case with other IDEs like Spyder. It grabs your output, condenses the output, volume of the output. So it will not be so clear. So Jupyter is highly recommended. If you're still passionate, I would suggest you guys to install PyCharm as well. But for the people who are not from the programming background, these two are very much good enough. Okay. This IDE, which is picking up in the industry nowadays, is gaining so much of fame. PyCharm download. This is basically from the organization called JetBrains. Just go to this download PyCharm link. So here you have two versions. One is professional version, the other one is community version. We don't need professional version. This is basically a licensed one. You can go for this community version, just click on download and install it. Because you already had the Python installed at the first place. Just the IDE that we are downloading and installing. And this is still compatible with Python 3.7 version. Okay. And the code remains the same. But being a new IDE, it comes up with little more new features. And it adds a little bit weightage to your profile as well. Okay. To get all these softwares installed, come with the laptop next session. We will be doing basics of R programming, basics of Python programming, and you can do as we learn here. The next session. I'll go a little slow. I'll give you some time to execute these things for you or for yourself, so that you don't get into the basic syntax issues and all those things. Right? Clear, guys? Online folks? So any questions with respect to the installations?
No questions.
Okay. Okay, fine. Let's wind up here for today. And we'll meet again next Saturday at 2 p.m. Right? Thank you. Thanks for attending.
Thank you.